Hey, this is Paul, and I'll be working on Advent of Codes Day 7, which is about wires being connected with each another and doing some kind of bitwise logic. Um, so when I started making these videos, I was mid day 7 and actually didn't go any further until I covered all the previous days. So let's have a example of downloaded. I've downloaded the input data, so we can look at the data already. So um, each line consists of instructions, which is, for example, the first line is not, which is a bitwise complement operation for some variable. At least at the moment of the first line, it's not known what kind of value DQ has, but when all of these instructions are read, they have to be resolved to understand. For example, somewhere there's an instruction how to make DQ. So in a sense, it's just an instruction how to connect everything, and like you just in a sense, let's say, get some electricity going through these gates. So for the first line, it's so the assignment is this right arrow. The left side of that assignment is what's being assigned, and the right one is the variable which the output will be, which will be the output of this assignment. So for this sense, it's a bitwise OR. I can probably give you an example of, let's say, so when it's bitwise, it means that it goes on binary in a binary algebra. So for example, if we have a binary number, let's say 1000, which stands for 8. Yes, so this stands for 8. If we have 110, it stands for 12. This stands for 14. No, wait. Yeah, that's 14. That's 15. Yeah, that's 15. Yeah, so let's say we have 1000. So the first calculation, it's just, I don't know. So not goes into 0111 for this specific example. If we have, let's say, some other number, let's say 1010 and or 1100, it goes into looking index wise. In a nutshell, it's just looking index wise. If at least one of the that specific index is 1, so for this case it's just 1110. There's also, it's not specific for this line, but there's also like AND operation, a bitwise operation, which does a bit different compared to OR. It looks for that both binary numbers at that specific index are positive. So at this point, it's just 1000, because like only binary wise, it's this index is 0th. This is the first, this is the second, and this is the third, so it's counted from left to right. And the rationality behind that is to actually to count that in a base of 10 to understand what kind of usually people use the metric, the numbers that change when they reach 10. No, I don't know if I'm putting this right, but I mean, for our decimal system, we have 10 values, which then move into another number. As for binary system, it uses only 2 values, which then move into another system, another number. For this example, let's say we have 1 0 0, or let's say probably the best would be just to look at all ones. So we start from the first one, which is 1 times 10, 2 to the power of 0, so it's index based. Then we add up to 1 times, this is the second one, so it's, it's the second, but like the index is the 1, so to the power of 1, 1 to the power of 2, and the last one is 1 to the power of 3, so it's going from right to left. So that's the basic rationality behind the binary numbers. So yeah, I mean, let me just clean this up. We can start working on the programming assignment, which is having all these instructions. We have to emulate it, the circuit, and we have to retrieve the wire A. We see the answer already, but we have to understand how to get to the wire A. So, okay. Before making all the reading, let's, we can like start with reading the data because it's the simplest part, but with opening the file, day 7. So since it's line based, let's just leave it right as it is at the moment, because since this requires some kind of a data structure, because we read the information and then we need to process the whole information into some kind of a data structure, which is capable of deducing one thing is deducing what kind of variable it is, and deducing the output, just like bitwise operations and or L shift, left shift, right shift. Left shift and right shift, I can give you a quick overview of it. So it just shifts it just shifts the value by some amount of by some amount, which is like if we have 0101 and then it's shifted by 1, then we just have the answer as left shift, so it just shifts the value by 1 to the left. So that's pretty much it. Either way, for Python, there's a bitwise operations. The operators are bitwise, and they're implemented, and you don't need some kind of additional logics on that. So I think that it would be good to predefine these readings, these operations, since Python-wise there's already operators on that, but for this specific task we can like do it just to get a specific value, a specific output for this problem. So let's create a class which will consist of these operations, and I'm not really sure if it's a good practice to do it like that, but so we will just use lambdas for every operation on that. So let's define 2 variables, and is just ampersand symbol. O is also done the same way on 2 variables, but it uses a I don't really know the name for this, but let's just call this tick symbol for this time. There's also not, but not needs only one variable, so let's just call it variable. And the not is this specific symbol. One thing there is when you invert it, like thing with binary is that it can give, depending on the compiling machine, which like gives specific values for a number, it can invert it into a way different value that we need to. That way we need, that is why there is a definition for a number which is up to 65535, so it's 65,000, and I believe, let me check, it's 16 to the power of 4, it's 16 to the power of 4, I believe. Yeah, it's the same number, at least that, it starts counting from 0 at this point, but generally it's the same number. So this means that we need to apply a mask on our output. We have to use AND to apply the mask. This is 0x, means that the following values belong to hexadecimal system. Hexadecimal means that, as I mentioned before, we have like decimal, which is from 0 to 9, and when it's 10 then you move into another number. For binary it's from 0 to 1 and then you move on to another number, and for hexadecimal it's 16 values. So when you reach 9, the next value is A, B, C, D, E and F, and then you move into another value. So it's just, there's no specific number for that, it's just some alphabet letters used for that. And yeah, binary, hexadecimal, and there's also octal that are most commonly used in computer science. So hexadecimal is pretty useful comparing to binary because it packs more data into one without if you would use binary expressions directly, there would be so much data that it would be quite difficult to read. At least for a person who is not that confident in understanding binary. So hexadecimal is less big in the sense that it can pack more bigger values without expanding so much in. So yeah, so we apply the mask, which is simply just, if I can give you an example, that if we have FFF and then we have some other number which is A, B, C, D, E, F, 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 so it will just chop off the part for that. So that's why we need the mask for that, and because it asks for a specific range of numbers, so it has to be within the range for this specific task. Okay, so we have AND or not. We have also L shift, which is two variables, is two side symbols to the left, and for arrow shift is we can just exchange places, but let's just use the same approach as previously. And also, so some of the values, I believe I've seen some of them, are simply assignments, like Lx is A. So ultimately there's no operation done on Lx, it just like give me the value of Lx and assign it to A. So let's just call the last operation assign, just to be consistent with having all the possible operations that are applied into the output. And so this is the operation, and we have to define ourselves a wire, which is a node in our data structure, which will be one of many nodes which will sum up our circuit. And when we want to start resolving what is where in that circuit, we'll just call that specific data structural node. We'll just call it a wire, because that's how it's called in the exercise. But so what it has is, so what it has as a wire, it has some kind of a name, it has inputs, and it has some kind of operation. So let's have a name, currently empty, because this is just a placeholder for now, and when I'll actually start reading the data, I'll be able to simply give everything, fill this up for each object. There's definitely a different name, probably different inputs. It might just be that some of the wires have the same inputs, and that's just the way it was implemented, I suppose. So we have inputs. We don't know how many inputs we have, because it can be either one that's not a good example, but it could be two variables, it could be one. So that's questionable. I can do it like assigning two separate variables for that, but let's just use an array for that, and an operation. I'll just call it an operation, and we'll just use operations. Let's say assign as the default one, which is like pretty much doing nothing. Another thing to have in mind, that since we don't create an object out of operations, and we explicitly use this assign lambda value, since lambda is working in a way like a function, we need to have it static. Static means that it's already defined, and you don't have to create a separate object for working for this class's variables at this point. So Python for this has a static method appliance, which means that each of these lambdas has to be init. And that's just because that we don't create a method, an object, but that's a good thing, because there will be a lot of wires, and creating an object of operations for each wire is I don't know, there's just too much resources used in waste, and we just have operations as the operations object never changes, it's like constant. So it's not useful to create a different object for each wire, and we can just simply use this class as a reference to the operations that we want to do. So yeah, I'll just finish this up. Okay. Yeah, so that's what we get, and we have to also have some kind of a placeholder for all the wires. So let's call it wires. It could somebody can have like any kind of different approach on that, but that's what I'm thinking at the moment. So we'll have a placeholder for this. We'll have a okay, so we'll have parsing function here, which just gives us the file. So we just simply do wires, and we give the f and something like that. let's say, oh, so we have to print A, I believe. We just do wires called A, just ask for the specific variable. Since we will have a dictionary of all the wires, which will be in the form of wire name, variable name, and wire object, which has also its name, but it's useful not to ask every wire, just to deduce what kind of name does it have. It's most likely that I'll just use this name for debugging, let's say. Yeah, so I'm sorry. Okay, so I think that we can start placing data in. For this point, I mean, we still don't know how to make, I mean, not know, but we might have some kind of ideas how to resolve everything from it, or resolve the output for a specific wire. But currently, let's just ask for, let's do the reading part, and later we will try to understand how should we resolve everything. So data is pretty interesting to read, I suppose, because I mean, it's space delimited, and it has a different amount of items. For example, this specific line has 4 items, this one has 5. And what we want, of course, is to extract the data. We don't care about the symbol, actually. I mean, every line has the same symbol, so it's just probably for readability. But so we know that the last symbol is output, so we can do simple items is equal line, which is split by space. So we'll have 1, 2, 3, 4 symbols, and in Python, if you want to call, or no, address, yes, if you want to address the last item, so let's just call it output is the this value. If we want to address it, we just need to call it from the other side by minus index, which means that if we want to get from left to right, which is from the beginning of the array, so this is the 0 index, this is the first one, this is the second, and this is the third. But what if we want to go from right to left, from the end, we have to, I mean, 0 is already used for the first one, so minus 1 is used for the last one, minus 2 is used for the second from the end, minus 3 and minus 4, and so on. I mean, I'm not sure, I believe that minus 5 just might be in the index out of boundaries, not some kind of looping. But for this point, we just care about the last symbol, which is this part. And I mean, all of the lines have the last one as the output variable. Okay, so for the right assignment sides, we have everything finished. Now for the left part, we have quite some differences. We have 2 items here, we have 3 items here, or we can even have 1 item. So I'll just go with a simple one. Yeah, I believe that. So, oh yeah. Also, I believe that beforehand it would be useful just to. I mean, yeah. Let's just do the one that which is like, depending on the amount of items, deduce what kind of. Let's just like split the operations to do the number of items. So if the length of items, I mean the size, is well, let's start with 3. So there's 3 of them, and that means that on the left side it's only 1, because there's always one for this specific arrow, and there's one for the output. So 3, it means like direct assignment. We can give it like operations. I mean, assign operation. That's even easier. So let's just leave it for now, and then we have to check if there's 4, which stands for not decay. Yeah. So not operation. Let's also leave this for this moment, and the last one. Well, let's hope that's the last one. But so that's AND or L shift R shift operations. Any of. So let's pass, and like as usual, just to be sure, if we don't expect some kind of length of an item, just like print or unexpected amount of items, and it's a good thing just to output what the actual line looks like. Okay, so for each of these clauses, I mean in this specific condition, we already know this assignment, that the operation is assignment. So that's I mean, for each cycle we just like have to do all of these things. So I'll just assign everything to an actual object in the end, but it's also possible to do that earlier, but I'll just do that later, I suppose. So I'll just call a new variable which is operation, and that's definitely operations assign. Even though we have a default one, we can like give it a none. It's probably a better way. I don't know. Operation assign. For this one, we have operations not, and now what we have here is if and line it's now we can check it actually. If items, this one, not this one, the second one is and then operations and else if items 1 is all, then operation is operations all. Else if items 1 is L shift, operation is operations L shift, and last one is right shift is operations R shift, and as usual we don't expect some things. Let's just I should probably also use single quotation marks for this. Unexpected expected operation. Oops. Formats. Items. Good. Okay, so we're done with operations for all of these conditions. And now we have just to assign these we have to assign actual wires. So let's see. I mean the inputs for a wire. So an input could be a simple variable which is unknown at that point probably, or it could be a number. So I already see that we'll probably need quite a lot of duplication of code if we don't create a function for finding out what the actual number is, if what the actual input is, if it's a number or something else. So let's just like check input probably, or yeah, let's parse input. And let's just call it input. So so we'll get a yeah, and we also need to create inputs array, and for this specific way, let's just for this specific example, let's just use one line just to have an idea how everything works. So items, so it's just assignment, so it's the first item. So we give it a string, and we want to know if that string is a number or if it's something else. We also need to know one more thing, which is, since we have a these wires, we need to know if this wire is already defined. If there's, let's say, if we want to assign not dq, the input dq for di, we want to know if dq is already there. I mean, if dq has some kind of also a some kind of formula, I mean, some logic behind how should dq be resolved. So we need to read the wires. So at first, of course, is like looking if the input is a digit. So there's a function called isDigit. If it is, so we just return integer for input. So that's pretty easy. And else we have to check one thing, is if input is in self wires, in the wires dictionary. Does the wires dictionary have this kind of a key? If it has, then we simply return self wires input. I'm sorry. Or we have to create it. So what happens here? We just do a self wires input is our so that's actually oh yeah, return. I mean, we'll have to return it either way. So let's just wire. Now let's just pass the name for it. I suppose it's pretty useful. Okay. Yeah, and like we just have to check if it exists. If it doesn't, we have to create it, and then just either way we just have to return a wire object for an input. So this is just for this item. Yeah. Let me think. Oh yeah. So we already see that we need to define a constructor for this class, which is self out here, and we also have self name. So self name is equal to name. That's it. Somehow lost space from here. So okay, so we have outputs, we have definitely operations then, so we have to simply get the inputs. So inputs append self bars input items. It's the first one because it's the second one because the first one is the not operation, just like this one. Okay, so this condition is fulfilled, and for all of these it's all the same. I mean, it's always the first one and the second one, so it's 0 and 2, 0 and yeah, this is the third one, so it's 2. Yeah. So inputs append self pass input items 0, and also append self pass input items 2. And that's it. So the whole parsing part is done. It also needed it only needed to parse this part, so it was pretty simple, I suppose. Okay, so let's just exit this conditional and create an actual wire and assign it to the wires. But one thing that we have to have in mind, that we have also, like previously, we have to check if it doesn't exist. We have to create it only at that point, because if it already is created as dummy, because this one creates an empty instance object, wire object, probably the best way of calling that. So let's just call W for this point. I'm sorry. Something's in my throat. Okay, so we create a wire, which is the name of the output. We also, well, wait, that's wrong. That's really wrong. So we have to check first if output is in self wires. So if it doesn't exist, we just simply have to create it. And then, I mean, it would be definitely bad, but if like there's several assignments for DP, let's say at this line there's this assignment, and later let's say this is for DP, like let's say this is DP, so there's 2 assignments and there's an override needed, so we'll just override everything. But that just means that this, if generally what it should be, I mean, if the data is all okay and it doesn't override anything, it's just like we create a dummy Y object, which is simply empty here, and we check if a dummy was created previously. If it was, we don't need to create anything. Also forgot that. We don't need to create anything, and we just go into assignments of specific values, let's say self wires output. So now we're referencing this object, sorry. So we have inputs and operation to assign. So let's assign the operation, which is called operation, and self wires outputs, inputs, which is also in the same it's the same concept that we need for. And that's it. And we initialized, we read everything, and that's pretty much it. So we have everything ready for the wire, and now we need to think a way of resolving the values and getting the output. So what I think a good way is to understand to like resolve and get the output is to create 2 functions in the wire, which one is, as I mentioned, resolve. So just self let's just pass, and output. So for output, it's pretty much an easy way, because like, you know, in the outputs, the perfect case and the actual case on should be that instead of these not numerical values, we have to have numerical values and just apply the operator on that, and that's it. So yeah, we should simply oh yes, I mean, there's also the case of how many values we have, but that doesn't really kill us at this point. I mean, so we just need to check the length of inputs. How many inputs do we have? If we have, let's say, one input, then we have to, let me think. Yeah, so we just have to return operation and inputs 0. So that's only the one that we have. Or yes, this one, return operation. Also have to, I mean, it's always a good thing to always define what you expect in specific condition and just use else as a unexpected condition wrapper, just not to miss something out and make it difficult to debug later. So let's just use this as there are more than 2 variables, and so since we have the name, we can simply refer the name. And we of course forgot referring to the inputs also, since they are class variables. Okay. Oh, I forgot everything for that. Okay. Yeah, so that's a pretty simple appliance, because the only thing that we care about is the amount of inputs, because our lambdas require either 2 variables or 1 variable, and that's it. Now for resolving, it's a bit difficult to tell, but looking at the why we have some things that how to call that, so it's probably best to draw that. Create a new diagram and bland diagram, and that's created. Okay, so I'll just make some simple, let's call it, this will be our buyer object, which is actually some only, I mean, in the end it's just some kind of an object, an output. So let's create a bunch of them. Doing something. Okay. It seems to be really dwelling into the depths of lag. I mean, could you please make some more, please? Okay, so let's say we have, let's say 3 input variables, which will be definitely numbers. Let's say 1, 0, and let's say 10. Yeah. So it's probably better just to make it to double. Yeah, I mean two values just for to make it look better. So we have some input variables. Okay, this one, and let me think. Yeah, this looks good, I think. Okay, so we have A, B, C, D, E, and let's have a connection. So let's say one just goes into A straight, and it's just a simple assignment, so A automatically becomes O1, but at this point we don't resolve that immediately. We just say that O1 is the input of A and assignment is the actual action. We can probably also add some kind of, I don't know, I'll just use a comma and assign. Okay, let's use some more arrows, please. I don't get it, why is it? Okay. Let's probably use it like this. Or maybe it's okay for the walnut. It's like up into, up. I mean, it depends on my interpretation, what I want to have. I'm just like creating this randomly without, there's no point in creating something structured. It's just like whatever we make, it's definitely possible to make it, and it's not a big problem after all. So okay, we can draw this a bit lower. So A goes into C. Yeah. B also goes into C. Here we are. B also goes into D. Notation for this, and let's say C and E goes into E, and D goes into E also. Okay, great. Yeah, so let's say this is AND. Now we can probably do that by good. So remove the space. Or comma L shift left shift please shift and comma right shift. So let's say that we want to deduce what this specific let me think, what this specific output is. So what I'm thinking about is start to resolve things from its inputs. So let's say we start by iterating from E's inputs. So the inputs are C and D. So we go into C and we see that C does also have inputs. E is okay if the input is a number. So if it's a number, then he doesn't ask anything. But if it's not a number, it asks it to resolve itself because it's not a number, and it's useless for E because it cannot make this kind of smart decision. So C also has to, let's make it right. So C also has its inputs, and as we can see at the moment, they are not numbers. A is not a number and B is not a number. So C also asks its so since I'm just going for one cycle, I'm asking C to have some digital value, and I'm asking A for this point. I'm just going the left as the first one, so I'm asking A, and A is I don't know, purple one is okay. So I'm asking A, and A has one input which is actually a number, so that's good, and A just simply assigns it to itself, so we just say it's O1. Right. And it's done. I mean, it just returns O1 to C, and C has one input which is O1, then it asks another input which is B. So B uses AND for both of these are numbers, so it just calculates the resultant value, which is 0, 0 at this point. And it's also resolved, so B is already already has its inputs out here, and the only thing that when you ask B to resolve, it always just gives you 0, 0 at this point. So okay, so for C sees that it needs to L shift it by 0, 0, so it doesn't left shift anything, so it just goes O1, and E sees that C is already a number, it has its output which is O1, then it asks D for D's output. D unfortunately sees B as still, I mean B is always unresolved for it, because B has other inputs and it's not a number so far. So but the other thing is that it has other inputs which is a number, so which is pretty nice. But so since B is to be resolved, let's make it orange, I suppose, for this point. And this one, I don't know, blue. I don't know. I mean, the color notation is pretty useless in this at my example. Okay, so B again resolves itself. I mean, it's just consistency to keep the input values without losing them and always make the calculation. I mean, that's one additional calculation each time when you refer to the same variable, but that's what I'm currently only thinking about. So D gets the 0, 0 and gets the 1, 0, and the resultant is 1, 0. So if it does the right shift, I believe it should just return 0, 0. But this doesn't really matter. The only thing that we care about is not what it actually puts out, but how we resolve everything in this kind of graph tree. I don't know, I suppose it's graph. So for resolve, let's use the same logic. So the best thing to do is to I don't know, why is it going so slow, but okay. So we check for, oh yeah, so we have to go through all the inputs. I mean, it's okay to go through, put 1, input 2, but it's definitely easier just to cycle through all of them. And usually there should be much more than 2, so that's not a big problem. So for each input we check if it's a digit. Oh no, so we just check if it's of type int. Another thing that when I thought about it, okay, so instead of simple input we need to arrange it. I mean we will need to replace the input into a number just for the output. So we definitely need to understand where its place is in the inputs array. Okay, so if the type of inputs I is int, it's not int. Yeah. We ask to resolve itself. Inputs I. So it makes sense that in this example, if E sees that C is not a number, it says so AC just go and resolve yourself. So then C just goes into its inputs and sees that A is not a number and asks A resolve yourself, and A sees that its input is 0, 1, and it doesn't ask it for to be resolved, and it just returns the output of itself. So yeah, just return self output. Yeah, I also forgot the reference to this class. Oh, that's right. Another thing that I forgot. So since it resolves and it returns something, so it has to be assigned somewhere. What we ideally hope to get is to return into the inputs instead of some symbolic value. We need actual number. So yeah, I mean, that might look a bit complicated at first, but generally what we are doing is we're asking for all of these just to resolve themselves up until they get into the number. So it just climbs up into, it reaches some kind of a number, and it asks for it to resolve, and when it resolves, it returns into input, it returns into input, and it's like, I mean, it's recursion. And when you Google what is recursion, I believe I'm not sure why is it like sort of laggy. What is recursion? What the hell is going on? Recursion. What the? Yeah, so it's just a repetition, but it repeats itself on some different grounds, like having different inputs and so on. Also, another thing is that we probably want to get the output of A. We want to resolve A, actually. Yeah, because like getting the outputs, we already get the outputs which have numerical values. So this should work. I'm not sure. Let's see. So Python page 7 part 1. Oh, okay. It seems that there's a new line symbol which we need to, which we actually need to just strip off. Just remove the new line symbol. Operation. Yeah, so does it have it? No. That's interesting. So it doesn't have this key. That means that this specific pretty stupid mistake. Okay, so that's pretty much it. Okay. So we have part 1 as 3176. The error here was that my condition was flawed. It means that it's edged if it exists, and if it exists, it overrides. So it's automatically doing the wrong thing. So we definitely have to look for, if it doesn't exist, it has to define a new object for that, because there's no object at that point. So the answer, I believe, is the number that we got. Yeah, 3176. Okay, the part 2 is take the signal you got on wire A. So this answer is copied. Override wire B to that signal and reset the other wires, including wire A. What new signal is ultimately provided to wire B? Okay, so we let me think. Yeah, B wires B should sort of work. I mean, the other solution is simply changing the data, simply this specific value into this. But let's see if this works, and that would be interesting to see. Print is a resolve. Okay. No, it doesn't change. Yeah, so I mean, I'm not like really filling this through what's wrong in my code. I will just change this specific value and just reapply. And I got 14,710, which is the right answer. So yeah, thanks for watching. If you have any questions, yeah, you can ask it in the comment section, or you can actually ask them in the repository. Thank you for watching. I'll see you next day.